Hello, this is Mr. Waters, and we're going to do another example here from the homework, page 663, about rotated conic sections. And in this example, we're going to do the whole shot. We're going to determine the appropriate rotation formula for the rotated conic, and then we're going to substitute the rotation formulas into the conic equation, the original one, to determine the equation of the rotated conic. That is the equation with no x prime, y prime term. Okay, so we're going to be working with this equation here, 11x squared plus 10 rad 3 xy plus y squared minus 4 is equal to 0. Now here's what's going on. What we're trying to do here is that's probably some kind of ellipse like this. Now the equation in terms of the x and the y-axis is given by, the equation of this graph is given by that one right there. However, that's a little hard to work with. What we're trying to do is we're trying to rotate the xy axes so that they line up basically neatly with the major axis there of that ellipse, so that we will get another formula in terms of x prime and y prime, where we'll be able to calculate the a, the major axis, and we'll be able to calculate b, there it is, the minor axis, and we'll be able to find the focal points, which from this equation here we really can't do. Anyway, so the first step of that process, number one, is to calculate what the rotation angle theta is going to be. And our formula is cotangent of 2 theta is equal to a minus c over b. Okay? Well, there's the a, there's the b, and there is the c. c is 1. So it's going to be cotangent of 2 theta is equal to 11 minus 1 over 10 rad 3. Well, you can see that that's equal to 10 over 10 rad 3, which is equal to 1 over rad 3. So we've got cotangent to theta is equal to 1 over rad 3. Now, we don't have a button or a table that gives us cotangent values, so what we'll do is we'll take the reciprocal of both sides and get tangent to theta is equal to rad 3. We arctan both sides, so 2 theta is equal to arctan rad 3, and so that 2 theta, according to my calculadora, is 60 degrees. So therefore, theta, the necessary rotation angle is, over here, is 30 degrees. We have to rotate the black xy axis 30 degrees up to get that red axis, which gives us the simpler conic. Okay? Now, scroll down a little bit here. Now we take that angle and we put it, this is step 2, we're now going to put this into the rotation formulas to get the appropriate rotation formulas. Well, the rotation formulas are x equals to x prime cosine theta minus y prime sine theta, and y is equal to x prime sine theta plus y prime cosine theta. Now we just go ahead and plunk theta equals 30 degrees into that formula. Okay, so x, and I think I'll use a different color for this, x is going to be equal to x prime cosine 30 degrees plus or minus y prime sine 30. Okay, y is equal to x prime sine 30 plus y prime cosine 30. Now all we need to do is know the sine and the cosine of 30, and we're going to go, that will give us our formula. Okay? So cosine 30 is rad 3 over 2. Sine 30 is 1/2. So now we just substitute those values in. X is equal to rad 3 over 2. X prime, you see I just put cosine of 30 rad 3 over 2, where we see cosine 30 here, minus 1/2 y prime. See what I did? I just put the sine of 30, which is 1/2, into the sine of 30 part here. Y is equal to 1/2 x prime plus rad 3 over 2 y prime. Again, I put sine of 30 here, cosine of 30 here. Now, here's the thing. If you've got a problem in your homework, and some of your homework problems are like this, that only ask for the rotation formulas, then you're done. This is the answer. These are, as our book puts it, the appropriate rotation formulas. Now, if you're supposed to go further and actually determine what the equation of the rotated conic is, you'll take each of these, the x and the y, and substitute those back up into the x and the y spots up here. Okay? So, that's going to look like, if we had to do that part, now that we're going to call this, oopsie, we're going to call this step 3. Okay, so it's going to be 11 times the x, which is rad 3, that's that x right there, this entire chunk here. Rad 3 over 2 x prime minus 1/2 y prime squared plus 10 rad 3, there's the x again, rad 3 over 2 x prime minus 1/2 y prime times, see it's in the formula it was x times y, see here's the, going back up here, this was x times y right there, so we've got to put the x and the y down here. Here's the x there. Now the y is going to be, according to our translation formulas, x prime sine, oopsie, you know what that is, 1/2 x prime plus rad 3 over 2 y prime. There's the y we put in for the y, and then plus the y squared, so I'm going to have to bring this down to the next line, that's 1/2 x prime rad 3 over 2 y prime squared, there's the y squared, and then the minus 4 is equal to 0. Okay, so there is the equation. Now if we wanted to carry this all the way through, we would actually simplify all of those parentheses, we'd FOIL things out, combine like terms, and we would discover that the x prime, y prime term would cancel out, telling us that this conic section is no longer rotated, that it is in terms of a nicely, that it's oriented horizontally to a set of axes, the x prime and y prime axes. Anyway, but for our purposes, we're going to stop here. We're not going to do that whole messy simplification. Anyway,